Imagine standing in the middle of a modern AI data center. The noise is deafening. Thousands of industrial cooling fans are screaming, trying to pull heat away from rows upon rows of black server racks. Inside those racks is the infrastructure of the new global economy. Right now, one single company controls the vast majority of the intelligence layer on the internet. Every time you ask an AI a question, every time a new drug is discovered using machine learning, every time an autonomous vehicle navigates a complex intersection, it is almost certainly running on their silicon. But if you rewind the clock to 1993, the picture looks completely different. There are no massive data centers, there is no artificial intelligence revolution, there is just a tennis dinner in San Jose, California. Three engineers are sitting in a booth, drinking endless cup of coffee, trying to figure out how to make video games look little bit better. How does a company built for rendering digital polygons in video games become the central bank of global artificial intelligence? Is NVIDIA just a hardware vendor that got incredibly lucky when the AI wave hit, or have they successfully engineered a permanent monopoly over the future of human thought? Silicon Valley is full of origin myths. The Denny story is legendary now, but back in 1993, Jensen Huang, Chris Malacossi, and Curtis Prime were not thinking about neural networks. They were obsessed with a very specific, very brutal physics problem. The compounding world at the time was dominated by the CPU, the central processing unit. Companies like Intel had built massive empires on the idea of serial processing. A CPU is like a single incredibly smart processor. If you ask it to solve a complex math equation, it does it perfectly and very fast. But if you ask it to grade a million simple math tests, it has to do them one by one. It bottlenecks. For standard computing like writing a Word document or balancing an Excel sheet, serial process was fine. But 3D graphics do not work like that. To render a 3D environment in a video game, you do not need one complex calculation. You need millions of tiny simple mathematical calculations happening at the exact same millisecond to determine the color and lighting of every single pixel on your screen. The traditional CPU was fundamentally incapable of handling this. Jensen and his co-founder realized that computing needs a new architecture. They needed parallel processing. They did not need one smart processor. They need an army of 10,000 average students working simultaneously. That was the first principle that birthed NVIDIA. The early days were a bloodbath. There were dozens of graphic chip companies fighting for survival in the 1990s. NVIDIA nearly went bankrupt multiple times. They were operating on a knife edge, shipping products that were just barely good enough to keep the lights on. Survival meant winning ruthless bidding wars for PC gaming components. By 1999, they finally stabilized. They held their IPO and officially coined a new term for their creation, the GPU, or graphic processing unit. They even landed a massive $200 million advance to build the graphic hardware for Microsoft's first Xbox. For most companies, this would be the happy ending. You won the gaming market, you are highly profitable, you sit back, optimize your supply chain, protect your margins, and keep your shareholders happy. But Jensen Huang operates on a different psychological frequency. His leadership style is defined by a deep, persistent paranoia. He runs NVIDIA with the core belief that they are always 30 days away from going out of business. This paranoia forces him to look past quarterly earnings and place massive decade-spanning bets. And in 2006, he placed a bet that almost destroyed the company. It was called CUDA, Compute Unified Device Architecture. Until 2006, a GPU was a locked box. It only spoke the language of computer graphics. If a scientist or mathematician wanted to use that massive parallel processing power to run a climate simulation or sequence DNA, they could not do it. The GPU simply would not understand their code. CUDA was a software layer designed to fix this. It allowed regular developers using standard programming languages like C++ to dock directly to the GPU for non-graphic math. Jensen was essentially building a bridge. The problem was that was absolutely nothing on the other side of that bridge. The market for general purpose GPU computing literally did not exist. Wall Street analysts looked at NVIDIA balance sheet and panicked. Jensen was pouring billions of dollars of R&D into a software ecosystem for a phantom industry. Investors punished the stock. Financial media questioned his leadership. Why would a highly profitable gaming company tank its own gross margins to build a free software tool for academic researchers? Competitors like AMD and Intel focused on their core markets and watched NVIDIA burn cash. For years, CUDA was a massive financial black hole, but Jensen refused to back down. He believed that if you build the computing capacity, the application will eventually follow. He was trapped in the wilderness waiting for a spark. That spark finally arrived in 2012, and it came from the most unlikely place. The artificial intelligence community had been stuck in a long freezing winter. The theoretical math for deep learning and neural networks had existed for decades. The researchers knew how to build the models, but they did not have the hardware to actually run them. Training a neural network requires processing of millions of data points simultaneously. It is the exact same mathematical problem as rendering 3D pixels, just applied to data instead of light. A researcher named Alex entered a prestigious computer vision competition called ImageNet. His goal was to build an AI that could recognize objects in photographs better than any human-coded algorithm. Because researchers did not have funding for massive supercomputers, Chris Sky bought two NVIDIA GTX 580 gaming graphic cards. They were cheap, they were available at any electronic store, and most importantly, because of CUDA, he could program them to run his neural network. His model AlexNet absolutely crushed the competition. The results were so disruptive that they sent shockwaves through the entire computer science world. The AI winter was over in a single afternoon. Deep learning was no longer a theory, it was a validated reality. And every single researcher on earth suddenly realized that they need NVIDIA GPUs to do their work. The dormant software ecosystem that Jensen has spent billions building was suddenly the most valuable real estate in the tech industry. Because NVIDIA has given CUDA away to the universities for years, an entire generation of data scientists had grown up speaking NVIDIA's language. They did not know how to code for anyone else's hardware. This is the secret behind NVIDIA's true power. Hardware is eventually a commodity. Someone can always build a faster chip, but an ecosystem is a trap. CUDA created an inescapable lock-in effect. Even if the competitor built a silicon chip that was 10% faster than NVIDIA GPU, researchers would not buy it because none of their existing software would run on it. NVIDIA has unknowingly built the deepest moat in the modern technological history. Fast forward to November 2022, OpenAI launches ChatGPT. The world violently wakes up to the generative AI revolution. But what most people did not see was the infrastructure underneath it. The model powering ChatGPT was trained on an AI supercomputer utilizing thousands of NVIDIA GPUs. The gold rush had begun, and NVIDIA was the only company selling the picks and shovels. The unit economics of what happened next defy all traditional business logic. The NVIDIA vaulted past a $3 trillion market capitalization, but the most shocking metric was their gross margin. NVIDIA was maintaining margins in the mid-level percentage range. Hardware companies are not supposed to have 75% margins. That is the software territory. That kind of margin profile indicates absolute unfiltered pricing power. Demand was so inelastic that the tech giants were begging for allocation, paying whatever price NVIDIA demanded just to stay relevant in the AI arms race. Jensen Huang fundamentally changed the corporate narrative. He stopped talking about chips and started talking about AI factories. Historically, computing was about retrieval. You type a query into Google, a server searches for pre-written article and retrieves it to you. Generative computing is entirely different. You are not retrieving data, you are manufacturing intelligence on the fly. Jensen positioned NVIDIA not as a tech vendor but as the heavy industry of the 21st century. But with absolute power comes absolute vulnerability. By 2023, NVIDIA has a massive target on its back. They were no longer just competing with AMD or Intel. Their biggest customers were now their biggest existential threats. Companies like Google, Amazon and Microsoft could not afford to keep paying for NVIDIA premium. They began pouring tens of billions of dollars into developing their own custom in-house silicon. Google has their TPUs, Amazon has Trainium. They were trying to break the CUDA monopoly from the inside out. And then the ultimate stress test hit. NVIDIA did not just have to fight tech giants, they had to fight superpowers. Silicon chips has become the most critical geopolitical asset on earth. The United States government realized that whoever controls AI compute controls the future of military, intelligence, cybersecurity and global economic dominance. In October 2023, the US government dropped the hammer on the industry. They imposed several export control limitations, explicitly banning NVIDIA from selling its high-performance chips to the Chinese market. The ban was absolute. NVIDIA was caught in the direct crossfire of of a geopolitical Cold War. Wall Street held its breath. Was this the ceiling? Had the geopolitical fragmentation of the internet finally broken the NVIDIA monopoly? NVIDIA did not apologize and they did not slow down because global demand so heavily outpaced supply. They absorbed the geopolitical shock and reallocated their chips to Western tech giants. Then they out-innovated the impact. In June 2024, Jensen Huang walked onto a stage and announced the Para-Rubin architecture. He tore up the traditional 2-year product cycle and committed NVIDIA to a brutal 1-year rhythm. The Rubin platform was explicitly purpose-built for the next frontier of the artificial intelligence coming in 2026. Not just chatbots that generate text, but agentic AI. Systems that can reason, plan, execute multi-step workflows and operate autonomously across the internet. NVIDIA proved that while governments can draw lines on a map, they cannot stop the fundamental mathematics of parallel computing. NVIDIA stands today at the absolute peak of the global economy. They transitioned from a scrappy gaming company fighting for survival in Denny's booth into the structural foundation of modern civilization. They took a leap of faith on a software ecosystem when nobody else believed in it, and they forced the entire world to speak their language. The war for the future is computing is far from over. $1 trillion rivals are hunting them. Geopolitical tensions are rising. But for now, the intelligence of the world is manufactured on their terms.